guess we will kick off. My name is Mark. I run product management and go-to-market for Anjuna Security. And with me today are two really incredible guests that work in the financial services community. And in a moment, I'll get them to introduce themselves today. But we're going to be talking about some real-world implementations of confidential computing covering AI and ML and transaction processing as well. So let's start with yourself, Justin. Do you want to just quickly introduce yourself as well? I think I've got a quick picture here of us.
No, it's me.
Yeah.
Yeah, thanks very much for having me as part of the panel today. So my name's Justin Simonelis. I lead technology on a product called Arxis that's developed by the Royal Bank of Canada. And it's RBC's very own multi-party confidential computing platform. So I'm within a unit at RBC called Solution Acceleration and Innovation, and that's a business-sponsored innovation unit. And it's within our mandate to look at technologies that have the potential to disrupt banking in the next 5 to 10 years.
Great. And Parsa, would you like to introduce yourself as well?
Yeah, everybody. My name is Parsa. I'm one of the co-founders of Portal. Portal is a embedded finance and blockchain infrastructure provider. Essentially what we are able to offer is consumer-facing white-labeled wallets for various different applications and use cases, from cross-border payments to decentralized finance. And we're able to, our main goal is to make the usage of blockchain and Web3 completely abstracted away so that you get to use the technology without actually knowing what's powering what you're doing. We use multi-party computation and threshold signing schemes in order to be able to achieve that.
Okay, good stuff. So before we dive in, I just want to set the scene a little bit here, and just in respect to Anjuna's role, we're also a member of the Confidential Computing Consortium. I also lead the Cloud Security Alliance Confidential Computing Working Group, and just a little plug for that is if anybody wants to join that group, we're doing influential work in the Cloud Controls Matrix and related documents. Please pipe up and see me after the show. So just really briefly, where Anjuna fits into the picture here, as you may have seen from Ayal on some of the prior presentations, we're a confidential computing enabling platform. It's a software enabling stack that allows the various different types of target infrastructures, be they in the cloud or on-prem, to be consumed with ease, and to do that with a lot of powerful controls. And we'll talk about some of those today as well. We work across platforms, and indeed, you may have seen at the RSA show just recently, we also announced projects with our partners like NVIDIA, with the US Navy, and so on. So I'm happy to talk about those later. But today, we're going to really talk and focus on the financial use cases. And, Justin, let's talk about the Royal Bank of Canada first. From when you look at it, confidential computing, and how you see it as the vision, your vision in the future of its role with RBC and Arxis in particular. Would you like to elaborate on how it came about?
Yeah, so I think RBC's always been a leader in information security, keeping its customers' data private. And luckily, we recognized a number of years ago that confidential computing has the power to disrupt certain ways of interacting with clients and increasing our security and new opportunities for collaboration. So a number of years ago, we actually started looking at SGX technology even before it was generally available within the cloud platforms, and we started building POCs on SGX hardware just to understand the capabilities of confidential computing, start to establish some patterns. And we see it as a very significant development in secure computing, basically a belt and suspenders approach to security that I think is going to enable increased collaboration opportunities.
And there's also the privacy regulations that sort of fit into this as well, that add complexity when you're dealing with data processing at a more general level. Could you maybe just touch on that slightly?
Yeah, definitely. So we always want to stay ahead of the regulatory bodies and basically go over and above their expectations. But we're also concerned about some highly publicized cybersecurity incidents. And we saw confidential computing as a mitigating technology. But most importantly, it's going to increase opportunities for collaboration, which will ultimately lead to product developments that are going to benefit our customers.
Excellent. And maybe you could just double click a little bit more on ArcSys itself and its intent. You know, we've talked about it. I think RBC was mentioned on a few of the prior presentations. I think Mark Rosinovich mentioned it was one of his favorite use cases for Azure, and we're very excited to be working with Azure on this one. Tell us a little bit more about, you know, ArcSys and what it's really for.
Yeah, so right now, it supports different types of workloads, one that we call confidential analytics and another that we refer to as confidential inference, and that's going to be coming to market very shortly. But ArcSys models everything basically as data that comes into the platform and exits the platform. But while the data is securely stored within the platform, it can be, you can run SQL analytics on it, and a lot of very powerful multi-party use cases that can be unlocked with that type of workload. And then the inference workloads, which are going to be probably generally available on our platform coming in August, we see a lot of opportunities for audience building that are going to inform some of our marketing capabilities. But confidential analytics has already been used in production with a number of our clients today, and it supports some of our marketing and loyalty opportunities. So what we can do today is basically create SKU-specific offers. And what a SKU offer is, it's an offer whereby I can go to a particular merchant, purchase a particular SKU item, and there might be a discount described in a particular offer. A merchant has the ability to load all of their transactional data and SKU data combined in a data set into ArcSys, and across a number of transactional attributes, we can join that to RBC's data, and without seeing any of the merchant transactions and without the merchant seeing any of our data, we can identify who's actually transacted on a particular SKU item and then reward them for that transaction with either loyalty currency or an account credit.
So it drives more transactions, pleases the customer, and drives more business for both the merchant and the bank at the end of the day, ultimately increasing customer retention and other things. So it's a great win.
Yep.
So let's switch gears to you, Parsa. I'm going to jump across here, and I'll let you perhaps introduce a little bit about Portal, because you're also in this kind of purchase transaction world as well.
Yeah, definitely. So we essentially, the customers that we're providing our software to, their use cases vary greatly. So you could be a large institution with very strict security and compliance requirements, or you could be a smaller application that is still trying to find product market fit. And our infrastructure is actually flexible enough to be white labeled for both types of use cases. One of the things that we use, one of the key technologies that we use, is obviously more multi-party computation to power our infrastructure. However, security is still probably the number one thing that is important for us. So we've been able to leverage, for example, confidential compute along with multi-party computation to move certain loads or certain operations that we would essentially be running on our users' devices into the cloud by, again, leveraging confidential compute to be able to gain that trust. Now, you might be asking, why are you even wanting to move certain loads into the cloud? And it goes to the point of having to be very flexible. So we have a particular, for example, user in Colombia or in Brazil who might have an older generation phone, but it still is a customer of our customer that our software is running on. So we have to be able to provide for them as the same way that we're providing for somebody with the latest iPhone here in the US, or if somebody's using our infrastructure in the back end. But that's kind of like where we fit in and all the different constraints that we have to juggle.
Jumping ahead to where you're actually helping end consumers. Tell us a bit about the problems you're actually solving for people. There's the end consumer, what are they getting from Portal?
Yeah, definitely.
Institutions.
So this kind of goes back a little bit to why we started Portal, which is we noticed that in order for you to be able to do any of the kind of applications of blockchain and Web3, you have to go through a pretty strict process of like downloading a Chrome extension and going through self-custody. And we said, well, that experience is pretty bad. I mean, a lot of users stop at exchanges, for example, when it comes to blockchain for that particular reason. So we needed an infrastructure that actually gives a great user experience, a typical one that maybe you're used to today with a Web 2 application. And that was our North Star. That's what we wanted to offer. So we couldn't really cut corners in order to sacrifice security for better UX, because both need to be present. But at the same time, our main goal has always been to how do we abstract away blockchain and Web3 and give a very good user experience to that end customer so they don't even know what's going on under the hood. You use a credit card without knowing how the Visa network works, or pay somebody without knowing how ACH works. That's kind of what we were aiming to do, what we have been able to do.
And let's start there with you with regards to your vision for confidential computing and how it's actually used then at Portal, and maybe contrast that with maybe where you were before you started down this path.
Yeah, definitely. I'll give two examples. The first one is around, we use confidential compute or leverage it heavily in order to speed up our processes. Like I mentioned, there are certain computationally heavy operations that if you were to put on the end user's device, could take upwards of let's say 30 seconds to complete. That's unacceptable for a consumer-facing application that's used to maybe 1 second loading times. So we use confidential compute to take away some of the bottlenecks, such as prime number generations, into a trusted execution environment. That keeps the security and trustlessness of the model, especially when you have TLS termination happening from inside of the enclave. You have remote attestation, and the client is directly talking to the enclave without us kind of man in the middling anything. You're still able to keep that high security, but at the same time, you're cutting generation times or account setup times from 30 seconds to maybe 1 second now. That's one of the first cases. And then the second one is we have different backup options that we offer on our platform. You can be Google Drive. It needs to be user-controlled environment, and it's basically stored in the cloud. So we can use biometric authentication happening from inside of the enclave itself to be able to now provide a seamless experience, like for the user to open an application, do Face ID, and voila, you're able to actually access your wallet and all your assets and still custodying it by yourself.
So you've been able to streamline security, simplify, but at the end of the day, it's the user that's actually benefiting because they just get instant responses, which is what they expect.
Absolutely.
And 30 seconds on a mobile phone, sitting, waiting for something, it's like that spinning beach ball scenario. You don't want that.
You will probably close the application and never come back.
Right, exactly. Fantastic. Let's talk about the Arxis use case. So you've evolved with confidential computing almost from the start, but when you think about what you could avoid doing with confidential computing, maybe you could characterize that a little bit here. It's the scenarios of if you were trying to do what you've got today without confidential computing, where would the limits be?
Yeah, so even before we built the Arxis platform, we were aware of some other clean room technologies out there, a number of players in the market, but it's the fact that confidential computing protects data in use that's really foundational to our ability to give our customers the privacy guarantees that they actually need in order to hand over their data to us to be used within a collaboration. Prior to the advent of this technology, I think it was just far too difficult and too risky for others to embark upon those types of collaborations with a bank.
Mm-hmm. I certainly think I've seen that scenario in the past. I worked in the world of tokenization, data encryption, and those technologies are great, but they don't provide the full isolation from code and data and everything. So that's what Arxis is able to do.
Well, yeah, exactly. So Arxis prevents or at least mitigates risks from insider threats, curious system admins. It certainly mitigates some risks around hackers that may have breached your other layers of security. It can even prevent some issues related to malware that may have gotten into the rest of our supply chain. I see it truly as like an enabling, but again, a belt and suspenders approach to security.
Mm-hmm. Fantastic. Parsa, when you were looking at confidential computing, you were also, we've just talked about this, the kind of things that you had to do before confidential computing. You've been able to perhaps stretch the boundaries of performance and so on. What about the experience of you actually building to confidential computing? Maybe you could kind of touch on that, because it's often complex, and when you start to get into things like making applications that are aware of themselves in confidential computing with the attestations side of things and self-aware applications, that can get a little bit tricky. How did you handle that? And maybe tell us about that.
Definitely. So we originally, confidential compute in general was like a mind shift for us of how we approach certain problems. After we learned more about it, we were like, okay, well, there's a bunch of different use cases for us. But let's start with the first one, which was, again, the safe prime generation times. But the issue was, we said, okay, well, there's this thing called nitro enclaves that now we can leverage. How do we actually do it? There's so many different layers to it, aside from actually educating yourself to learn like what it is, how to use it, what is attestation, what are the different pieces that truly make your application implement remote attestation. And so we went through the process of doing like a pure implementation ourselves with AWS Nitro, and it took a very long time. There were so many different layers, from maybe a proxy you need to run on the outside that goes to vSOC, and at the same time, I think conceptually we were still learning the technology. And to put it in context, like, we are a early stage startup, so we can't really afford to have a lot of time on our hands to spend 3 months learning a technology, iterating on it, and be like, okay, well, maybe this path is better or whatnot. That's why we were able to actually leverage Anjuna to be able to say, well, all I have is this application that's a Docker container. How do I, like, the main question is like, how do I just grab this, throw it inside of a secure enclave and say, great, I achieved my prime generations and I'm able to now move on to maybe the next use case. So that was probably the biggest thing for us to handle, and probably the biggest unlock for us was to be able to, like, in speedy time, deploy these applications in secure enclaves.
And just on that point, one of the things that you often find with these types of target environments, and my own experience of this working in the HSM world, is that you either build for that target or you build for a different target on a regular compute platform. And so having a layer that allows you to build outside and then just simply deploy that into confidential computing in very short order, which is what we've done also at Arxis as well, that's a huge accelerant. But it's not just an accelerant to get something launched, it's an accelerant over the life cycle of that application, because Absolutely. When you have to have skills to operate, debug, develop in a confidential compute environment. When something goes wrong there, you need to be able to take it out and figure out, is it application logic or is it something to do with that environment that has an impact? Was that how did that affect the way you can go to market in terms of launching new products and things like that?
Yeah, definitely. I think, like I mentioned, it was very much like a mindset shift for us. One of our main problems was, well, one of the backup options, again, user controlled. So user cloud controlled environments are maybe your iCloud, maybe your G Drive. And we said, well, there's also this like passkey thing on devices with biometric authentication. How can we leverage something like that to store these secrets and only have the user have access in like a trustless environment? We were asking the questions without actually knowing the answer was confidential compute, until we were able to first deploy the first use case of safe primes, and then saying, well, if this took us 2 weeks, we can easily just do our regular development lifecycle, integrate it into our the CIs that we have today, and do a local test very easily, and that local test becomes what you end up eventually running into production with maybe minor tweaks here and there. And that is very key for us, especially as we want to move fast.
And not have to have dedicated skills just to that area.
Absolutely. Yeah. And I mean, ultimately, it also helps us as a business to be able to close customers faster. When we have a feature request that comes in that's like, I don't like G Drive or iCloud, my users don't use any of that stuff, what else can you give us? I don't know, but with confidential compute and knowing how fast we can deploy it, we say, okay, well, we can actually implement a feature for OTP backups with WhatsApp. All authentication happens from inside of the enclave, and we can get that out in a month or so.
Yeah. Now, Justin, you've got a similar story. You've felt the pain from the very beginning of ground up design. Maybe you could tell a little bit about, what it takes when you think about that challenge. You've got the skill sets, you've got it's hard to estimate your timelines for getting something to market. How did you accelerate things?
Yeah, so like I mentioned previously, we had a lot of experience with particularly SGX technology from the very early days. But we found it to be somewhat inaccessible to the broader engineering team. We had one rockstar developer that was basically developing all of our Enclave resident code using very low-level frameworks and doing a lot of his development in C and C++. The vast majority of our developers are used to working in higher-level languages like Java, C#, Python. So when we went beyond, or when we had a desire to go beyond just confidential analytics, that was basically built with most of these lower-level SGX libraries, we needed something that could accelerate the delivery of confidential inference. And that's actually when we turned to Anjuna for a little bit of help. And there's actually a bit more of a backstory there. We were having some stability issues with our existing Enclave code, and I thought that Anjuna's SGX run C-Glass product could actually help us with that. But then we saw that given the nature of the product, we could probably really accelerate our confidential inference capability. Mm-hmm. And we started working with your team on some POCs, and then our developers very quickly were able to actually build confidential inference directly into the Arxis platform, leveraging the C-Glass tooling. And now we're at the point where pretty much half of our engineering team on a regular basis is contributing code that runs within enclaves mm-hmm. because of the productivity gains that we achieved through Anjuna.
Yeah, and certainly when you're operating a very lean and early go-to-market on this, that's super important, is time to market, and also time to that customer feedback about your own customers as well. Tell us a little bit about the customer experience, and maybe you just outline kind of what a customer uses Arxis for and what that might look like a little bit, just to set context.
Yeah, so Arxis primarily is just a collection of APIs, but sitting on top of that is the Arxis web application, which is really kind of a reference application implementation of our APIs. And the web app itself doesn't really have much of its own smarts. It just consumes the APIs, but it deals with everything like interpreting attestations based on the attestation. Should it establish a secure channel with the Arxis platform? If all of that's in order and the attestation looks good, the web app knows how to marshal data on the client side, encrypt it on the client side, negotiate Diffie-Hellman keys, load that data into an enclave securely. And then it also has an interface for creating collaborations, establishing policies around what can actually take place within a collaboration, who can upload what data, who can execute jobs. So it's kind of an end-to-end user interface experience for defining secure multi-party collaborations. And we kind of like to think of those as a form of digital contract.
Mm-hmm. So essentially a collaboration clean room for AI, ML engagement.
Yeah, exactly. ML and analytics as well. Yeah. And we're working on a bunch of other features that I wish we could talk about as well.
We're coming up on time, and I'd love for you to give maybe your thoughts and advice for anybody that's starting to embrace on a confidential computing journey. Maybe, what would the maybe top couple of things that you would recommend anybody starting to kind of look at and think about now? And I'll start with you, Parsa. I'm going to put you on the spot.
Yeah, I'll mention one thing that I forgot to mention, which is even if you end up figuring out like the different pieces that need to come together for you to have like an end-to-end solution with confidential compute, it's very easy to forget that needs to get reviewed and audited by other professionals as well to make sure that you're not messing something up. And that piece for us was pretty big, again, like because time is of the essence and we need to like deploy things quite fast. I'll also mention that what I'm very excited about with confidential compute, just from last year to this year, and seeing the emphasis on let's make it abstract and as easy to use as possible, is that internally we've been able to achieve something similar where I did our first implementation that took me maybe like a month and a half to 2 months. The next iteration that we had took about 2 weeks to deploy, and it wasn't even me doing it. It was just another one of our back-end engineers. And we knew what the service was going to be. We designed a regular service that you would deploy maybe in like GCP Cloud Run. And we said, okay, this is how it runs in Cloud Run. We can easily bring it into a trusted execution environment. So that's definitely an area that I'm very excited for to get better and better over time.
Yeah, and the third-party audits, I mean, that's something that we take care of essentially, which is...
Absolutely.
It's a significant effort that requires coordination. Justin, how about yourself here?
So, the conference this year, I think, is pretty much doubled in size, and I agree with some of the other speakers. I think awareness is growing. But I can probably speak to my experiences within a very large organization, such as the Royal Bank. I think you need to set up a center of excellence, that might be 1 or 2 people that really understand the technology and understand where it can best be applied. And you're going to have to be prepared to act as an evangelist and educator. And my team and I have been doing that for a few years now, and it's definitely paid off. There's definitely a far more awareness of what this technology is and what its capabilities are as compared with a year or 2 ago.
Yeah. Thank you so much for spending some time with us today. Obviously, we're all here at the conference. If you'd like to talk to us one-on-one, then we're more than happy to. And if there's anybody that has a particular question, I think there's a microphone here if we have a little time for one question. Nobody's game to step up to the mic. Well, certainly we can take that one. Oh, there's somebody over here. I can barely see you with the spotlights.
It is very hard to see.
Yeah.
So this one is specifically for you, Justin. Why did you decide to insource the development of this platform as opposed to going with like a more...
Yeah, that's a great question. So ArcSys is basically the end product of a number of generations of confidential computing products. Solution acceleration, the department I work in has been looking at this technology since about 2015. And through these successive iterations, we've been adding more and more capabilities. And it basically just got to a point where we had a product that was ready to go to market. And in its current form, it works very well. As for any future additions, we are working with partners like Anjuna to help expedite the delivery of some of those capabilities.
Thank you.
Great. Okay. Well, certainly, thank you so much. I hope you enjoy the rest of the conference. And also, thanks to the AV guys for making this super simple as well. Appreciate it. Okay.